Hello everybody. In this video, I'm going to take you through the ins and outs of graph analysis. Graph analysis is very interesting for helping us understand nodes and vertices and understand the relationships between people, places, objects, how things move, how things are transferred. And we use it to analyze edges and links. These are relationships between the interactions of those entities. So classic examples would be your account on Facebook and all your friends and the friends of your friends, all your contacts on LinkedIn and all the people who they're connected with, and so on and so forth. So very interesting, very powerful type of analytics. We look at a couple different things, directed and undirected edges. These show one-way or two-way relationships. And then the weights between the relationships. This could be, this is always going to be numeric, and it could be a higher or lower weight. It could be a distance traveled. We'll see several examples of this. So some very common applications for this type of network analysis is social network analysis, and that's looking at the relationships between people on a network. Of course, LinkedIn and Facebook are classic examples. Also, network optimization, finding the shortest path, optimizing routes between travel points, sources, and destinations. But it's interesting that this type of analysis is so powerful and so flexible. You can also use it for fraud detection, recommendation systems, and anomaly detection. We'll see a couple examples of these in just a minute. And there are specific algos that are very useful for fraud detection, recommendation systems, and anomaly detection. But it's also quite interesting that you can use this type of approach in this methodology as well. So let's look at an example of a social network here. We have 5 users, A, B, C, D, and E. This is just generic data that I made up. I don't have actual data that represents people on the network. But if you do, all you have to do is copy and paste that in here and run the code, and it's going to do exactly what you expect. I made the script very dynamic, so it can take any kind of input. But again, in this example, I'm just coming up with a generic but a very relevant source of essentially made up data. So let me click this cell, run it to refresh it. You can see the community is A, B, C, D, and E. And the suspicious communities look like it's A, B, and C because they have several connections. So each of these people, each of these users should have one connection. Anything more than 2 is going to be considered suspicious, because why would you have more than one Facebook account? Why would you have more than one LinkedIn account? Like, you would have one account for yourself and that's it. You could have, I suppose, you could be the owner of a community and an individual account, and the community could be people that have a certain common interest, but that's really a different thing. We're looking at individual accounts here. So if you have more than one account here, that's considered suspicious, and this network analysis just helped us understand that. So here is an example of potential credit card fraud. You have different transaction amounts, you have different merchants and different users. So again, pretty straightforward example, very relevant, and very simplified too. So you have user 1 shopping at merchant 2. He spent $500, and this is user 2 shopping at merchant 3, spent $4,000. We're saying, show me anything that has a weight greater than 400. That's the cutoff, and that's the threshold in this case. So that is working fine. Let's move on to a recommendation scenario using network analysis. So here you have different users, Tom, Dennis, Tim, and what they're buying is laundry detergent, fabric softener, dish soap. This is a list of items. It's named interactions. This is a list of all the items in their inventory. Again, simplified, but it proves the point. All you would have to do is copy and paste in your specific data set to run the analysis on your data. And I'm saying if the user bought dish soap, in this case, let me do Control Enter to refresh it. If they bought dish soap for Tom, we would recommend laundry detergent and fabric softener. And I think intuitively that makes sense. Here's a very similar example, just set up slightly different. This is content-based filtering. So now we're looking at content that has similar features: dish soap, laundry detergent, and fabric softener. In the previous example, it was collaborative filtering. So filtering between users, I'm sorry, item-based filtering. So filtering items that are similar. In this scenario, we're doing content-based filtering. So based on these items right here, if somebody bought dish soap, what other items would you recommend for this user? It would be laundry detergent and fabric softener. So there's a couple different ways to do recommendations. This is content-based filtering, and this example shows item-based collaborative filtering. And don't worry about all the details of the code. I'm going to post it. You can have all this code online available. All you have to do is copy and paste it, and then run your specific data set over this code, and you'll get the results that you would expect. So here's an example of using a network analysis to find anomalies or some type of outlier. So in this example, again, I'm generating data. I don't have anomaly data handy, but this essentially is doing what a clustering algorithm would do, and it's taking all the homogeneous data points, coloring those yellow, and then highlighting the anomalies or the outliers and showing those as red. So it's easy to see the numbers here. And you can see here's the short list here. It corresponds from 0 to 80. And if you look closely at the data points, I see it right here, 0, starting with 0 goes up to 80. So doing just what we'd expect it to do. Here's a transportation network problem solved using network analysis. Again, we have source and destination. These are airports. We're traveling from New York to Boston in the first case, New York to Chicago in the second, and then weights assigned to these. So some are arbitrary, but it is looking for the shortest distance between these points. And this network analysis scenario just ran, and we are saying, okay, we're going from New York to Boston to Denver to San Francisco and then to Los Angeles. And the shortest route would be 4. You can see the 4 and the 5. Add them together, it's 9 plus 2. That's 11. Plus 6 is 11, 12, 13, 14, 15, 16, 17. Okay, took me a second to figure it out. That's 17 steps to get from New York to Denver, San Francisco, and Los Angeles. If we did, let's see, that was, what did we say, 17, right? If we did 8 and 6, that is 14. Or 10. New York to Chicago would be 2. Chicago to San Francisco would be 10. Is 12. San Francisco to Denver would be 13, 14. And then 6, that's 20. So that route is longer. So if we have to travel from New York to go to a conference in Boston, a training event in Denver, then go to San Francisco to meet a client, and then move on to Los Angeles, maybe that's the last stop in our vacation that's starting, that would be the shortest distance to travel to those 5 cities, or from New York to the other 4, right? So let's look at one more using latitude, longitude coordinates. Again, finding the shortest route. So we're optimizing the travel path here. And don't worry about all the code. You can copy and paste it. Once I post the video online, I'll supply all the code. So don't worry about that. From New York to Los Angeles, we can see the most direct route is 3,944 kilometers. So that should make sense. We could go New York to Chicago and then Chicago to LA. I see New York to Chicago is 1147 and then 2809 to LA. So if I do 2809, 1147, let me look at this here, 2809. And then sum these two, I'm seeing 3956, so 3,956 kilometers. 3944 is a little bit less, 12 kilometers less, right? So we could go New York to Chicago, Chicago to LA, but it's 12 kilometers shorter, and you'd have a layover for sure. So definitely New York to LA is going to be the best route. Let's look at a couple more examples. I'm going to supply the data source for you. This is coming off of my laptop now, but I'll give you the source data. It's from Kaggle, so you can copy and paste that into your machine and run this analysis, or literally just run this over your specific data and and it's going to be relevant to what you're doing. So this is airports and origin destination flights. I have some latitude longitude coordinates, and then city, state, airport names, things like that. IOTA code, we can use that to link to the code at either the origin or the destination airport. So that's going to be the common denominator there. So here we're getting the network nodes. So the first thing we see is JFK to LAX, right? So New York to Los Angeles, we see the first node here. That's what it's doing. It's creating all these relationships like we've seen in all these network graphs. We are going to go ahead and look at the total number of airports here, 2,645. That represents this over here. Oh, I'm sorry. You know what? It's just IOTA code, longitude, and latitude. That's all it is. Okay. Now we're gonna, for the last thing here, we're gonna plot this on a graph to make it intuitive and pretty easy to understand what's going on. I'm gonna click on the cell, hit Control Enter to run it. It's gonna refresh. Some of these airports have missing data, so I'm gonna skip over those. Otherwise, we're gonna have an error here, and that's gonna be kind of ugly. Okay, so we have our plot right here. This is pretty nice, pretty intuitive, easy to understand. The bigger circles represent more flights. Dallas Fort Worth has 348. Denver 231. Or D, what is that? Is that Chicago or something? I guess it is. Or D has 268. Anything that's red is actually has 0 flights. There's no flights going into that city, because originally we started with 5 million records. We got it down to about 2,000 just to make this run a little bit faster. If we waited for all 5 million to run, that would take a while actually. So we're just looking at a smaller subset just to illustrate the point. And then when we zoom in, we can see the number of flights between airport. Again, the size of the circle indicates higher counts of flights, and then we can see the lighter blue lines between the airports show the travel the travel path for the airport. Over here is Hawaii, so I think we got what we want using network analysis. So pretty useful, pretty interesting type of tool. Again, useful for social network analysis, Facebook, LinkedIn, classic examples. Shows you the representations or the relationships between individuals. On large networks, it's going to take a long time to run to do a full analysis to be comprehensive about all the connections. But it is what it is. If you set this up and run it and walk away and go get lunch, it'll probably take a while for the algo to run. But slowness is a drawback, but it's going to be very comprehensive and complete and show you insights that you wouldn't get otherwise. So like we saw before, fraud detection, recommendation systems, it's great for that. We saw a couple of use cases. Anomaly detection, we explored that use case, so very, very insightful, very advantageous to look at it using a network analysis approach. And then pathfinding and optimization routes. So we saw how to do that. Again, very useful, very practical. Lots and lots of use cases for graph analysis. So that's pretty much it, guys. Here's the source code. Here's the data source. I'm going to share all the source code for you so you can copy and paste it and run it, see the functionality of how everything works, understand the logic. I'll post that as soon as I post the video. Like I do with all the other videos, I always share the source code so you don't have to retype it or obviously that would take a long time. You could easily make many mistakes. All you have to do in this case is just copy and paste and run it. So hopefully that was interesting. Hopefully you learned a thing or two. As always, if you have comments, please provide any comments. Hopefully this was helpful for you. If not, that's fine too. Let me know. I can tailor these videos and customize them in an infinite number of ways. And if you have ideas for future videos, things you'd like to see, you look at this and say, oh, this is interesting, but what about this scenario? What about that? What about this other thing? If you have some innovative ideas you want to share, post those too, and I'll take a stab at that and try to come up with some different types of analysis, looking at these things from a different perspective, and then I'll record a video and post all my source code so you have that too. Okay, thanks for everything. Have a great day.